Hello my friends, welcome again to my video channel. Today we will start a new project, Kenwood TS 450S. You see nothing. There's a reason for it, because the transceiver is still in its box. In general, I don't like unboxing videos. What's this? Never expected. Wow, that's great, and so on. And all this rubbish. No. But in this case, I will show you a perfect package which I received yesterday. The owner provided a box, styrofoam. On the side here there were some card papers. This was the top here. This is a wooden box. He provided two handles, or one handle with the strings, and now I can take it out. I hope nothing happens. I will squeeze it with my feet. You see what I see first. Oops! It's a wood shell, cardboards, again wood. This is a front panel. The owner promised me to protect the faceplate. I can confirm it is protected. I hope I can open it without damaging it. A very solid box. Very solid. I have to note the position of the cardboard and the wood for the... Well, let's start with the problem. The owner claims whistles, a lot of whistles in the amateur frequencies on 80 meters, 40, 20, 15 and 10 meter. Nothing on 160 meter, 17 meter and 10 meter. 30 meter is not mentioned. But in general here he has a lot of whistle tones. He claims 120 frequencies outside amateur frequencies. And he also mentioned in the email to me that he has problems in transmit similar whistles, not only in reception. He also wants me to check the receiver sensitivity and the alignment. Well, first we will check what the whistles are, what is meant with whistles. Now let's check whether we have some birdies. The first should be on 689. There is one. I'm not sure whether you can hear it. And I found when I switch on AIP, it gets stronger. AIP is advanced intercept point. The preamplifier is switched off in this case. The first amplifier in the chain. Okay, there's a birdie. I've checked also other frequencies. 7040 should be one. Can't hear anything. Maybe there's something. 7076. When I switch off AIP, signal increases, and so on. I could find some of these birdies confirmed, others not. What can it be? Well, my first assumption when I heard this from the owner, parasitic oscillations, but these are not parasitic oscillations. The frequencies are very stable, can be reproduced exactly. So I think it's a problem with shielding, maybe bad grounding of some of the boards, bad shielding of a coax cable or of one of the boxes, metal boxes, bad connection, whatever it is. I cannot decide it from outside, so we will open it. In our next step we will check the VCO and the PLL, the tuning voltage of the VCO. There is a test point. I connected the probe to it. It's a little bit difficult to show it because we have a lot of wires. I cannot unplug it, otherwise we have no function. So I only could bend it a little bit up, isolate it to prevent any shorts. The board is underneath. It's the PLL unit board. As we can see, there are some inductors for the various frequency ranges, and here we have test point 2, check point 2, where I connected the voltmeter, which indicates the tuning voltage for the VCO, and there are some voltages given in the service manual, and they are stated. At the moment I adjusted the transceiver to 30 kilohertz, and in this case the voltage should be 2.5 volt, and when I increase it to 10.49 megahertz, 10.49, should be 7 volt or less. Okay, the 6.0 something, that's okay. Next voltage is 10.5. Again 2.5 volt. And when I go up to 21.49, should be 7 volt or less, that's also okay. 21.5, it should be 2.5 volt. Okay, we have 2.4 volt, and on 40 megahertz, there seems to be a typing error in the manual. Cannot be correct. The maximum frequency I can adjust is 29.999. That's the end. I have chosen 1 megahertz steps. The tuning voltage is approximately 4 volt. I think there's a mistyping for the version of the TS690S, which also includes the 50 megahertz version. Okay, but we see the tuning voltages are in a reasonable range. If not, it could lead to a different L to C ratio, which could cause problems, but we don't have any problem here. So I will check the next VCO. It's the VCO number 2 and another test point. I connected to a different test point. Test point 3 now. Voltage should be 5 volt. We have 4.3 volt. Okay. Maybe there is a problem. It has to be adjusted with TC1. There's a trim cap. I will try to readjust it for 5 volt. Well, that is the maximum voltage I can obtain. So I think it's a part of the design. The tuning range is very small of this capacitor, so I don't touch it any longer, but it's obviously okay. we have no problems with it. Obviously we have no problem with the PLL circuits. The VCOs and the setting ranges are okay, except this voltage, but I think it's not relevant. Yes, it's okay. Switch on and off. So I will bring back the boards into the original position. Next topic I have to check are the ground connections of the board, whether we have all screws tight and fixed properly. This could be a problem. Also the ground connections of the coax cables. So I will bring it back into the original position and check it. In the next step we will check some alignment steps in the manual regarding the RX or the RF unit, not RX, sorry, RF unit. First check is the VCO level of the LO2. It should be in the range of 800 millivolt, and it is. We can see it on the screen of the scope. I've adjusted the scope for the measurement of frequency, and here you can measure the volt peak. And when I go to the checkpoint, it is here, we can see we have a signal of approximately 9900 millivolt peak. You can see here times 10, so we have 1 volt peak, which is the requirement of the manual. It says 800 millivolt. That's okay. There are some balance adjustment for the mixer, but these are only for TX mode important, to reduce the spare in TX mode, so the oscillators are suppressed in TX. There's only one mixer balance for receive, that is VR1, which is here behind. And this I've checked it, it's also okay. It's a mixer balance. It should be balanced at low frequency for minimum AF output, for minimum noise. It is okay, but it has nothing to do with the spare with the birdies we have. So this is not the case, not a problem. I think we come to the end, and maybe we can analyze the problem in this transceiver, but not only this transceiver. I think it's typical for all transceivers of this age and this technology. I set it to one of the spare. We see the output of the speaker. You can hear the speaker, the noise. Watch the amplitude, watch the tone. When I squeeze down this board, the RF board, the amplitude goes down. Well, I loosen some of the screws of the RF board, and then the board is not squeezed down onto the chassis. It's hanging in the air, and when I squeeze it down it gets better. This means all the screws have to be tightened and have to be firmly sitting on the board or on the chassis. There's one problem. The board have the contacts on the bottom layer to the chassis, and over the decades the boards are shrinking a little bit. We are talking about some micrometers or so. It may be if there is a solder on the bottom side which also shrinks a little bit, so the screws lose tension and the board has not a perfect ground connection. In this case I'm simulating it. I opened the screws, but when you have such a no transceiver, it's a good idea to check all the screws and to give them a short twist quarter of a rotation, half rotation or so, not more. Whatever is possible without damaging it. Do it with all screws you can see. And also reseat the coax connectors. More we cannot do. The problem here is we have a rather open architecture. You see the boards are open. We have wires between the boards. They are all not shielded. Yes, this board is grounded. The RF cables are shielded, but the other cables are not shielded, and there are also no ferrite beads on it. Some of them I've seen on the other side have some ferrite beads, but in general there are no ferrite beads. This means that the wiring is rather open for any HF coupling. Remember my last video about the Rohde & Schwarz EK070. Each unit had its own shielded box, a cassette, and inside these shielded boxes there were additional shieldings, and the top and the bottom cover of these boxes were fixed with screws, dozens of screws around on each side. So we have a perfect shielding. All cables or wires are equipped with fed-through capacitors and chokes, resistors in series, additional damping capacitors to ground, and so on and so on. This cannot be compared with this unit here, or vice versa. This unit here cannot be compared with such a commercial unit, and that's the reason of the problem. It cannot be improved. It is a part of the, or a result of the design of such transceivers. Imagine the price difference, and you know what I'm talking about. So I think we are at the end of this project. There is really no project. I cannot improve it. I didn't find a problem, a fault inside this transceiver. There's only some some design flaws. But to prove it, to improve it, no chance. We know why we have the problem, but on the other hand, it is not a problem. The birdies are so weak that they are not relevant. So one thing remains to be done. That's the setting of the reference oscillator. The reference oscillator is not correct. Should be 20 megahertz. Oops. And you see the 20 megahertz has an error of approximately 350 hertz. The alignment is done. Now we have 20 dot something, 2 hertz. Maximum error is 50 hertz. Here we have a different reference frequency on this board. 375. Okay, 29. Should be a little bit less. All these trimmers are very touchy. 29, 31. Okay, that is good enough. Well, the check of the alignment is done, and we can finalize this project. Also, the lithium battery is checked. It is located behind the front panel. Can be checked, 3.3 something volt. That's also okay. A short check of the output power on all bands. It's okay. We can go down to or up to 10, 14 megahertz. 28, also 29.99. We always have 80, 90 watt output. That's okay. Maybe we can increase it a little bit with carrier and power setting, but not necessary. So we can say the transmit path is okay. And now I make a short check of the receiver sensitivity. A short check of the receiver sensitivity also proves that the transceiver is okay. We have a signal of 0.3 microvolt on 29.8. When I switch it off, nothing. Sorry, it's 0.1. That's 0.3 microvolt. So the receiver is very sensitive, even on 10 meter, where sometimes receivers have a problem, but in this case we have no problem. Now we can go down to other bands. That's the other end of the bands, 1.85. You can clearly hear the signal. That's it. Now we'll check the S meter. The signal is now 50 microvolt. We have a little bit more than S9, but when I switch to advanced intercept point, the S meter drops a little bit. The attenuator also works. Yes. 4, 5 S units. Okay, this S meter isn't also the best one. It's a known problem of all S meters. But in general, I will say the receive path also is okay. And we have no problems. Summary and some conclusions. The owner claimed birdies. Yes, the birdies could be identified, but I couldn't find really any fault creating these birdies. These birdies are part or a consequence of the design. We discussed it. The shielding has some potential to be improved, but it isn't. It's a consumer grade equipment, not a military grade equipment. The boards are not shielded against each other. It's more or less everything concentrated on some boards with open wiring between. In general, we have to live with it. There is no possibility to reduce it. It would require a complete redesign of this transceiver. All these transceivers from different manufacturers are suffering with birdies, more or less. It is a consequence of the cheap design, and I cannot improve it. I have to say it is as it is. Sorry. Stay healthy, stay tuned. See you on this channel.